Question 11 of Mathematics Paper 1 for June of 2024. 11.1. Two events A and B are such that the probability of A is 0.4, the probability of A or B is 0.52, A and B are mutually exclusive. Calculate the probability of B. So when events are mutually exclusive, that means the probability of A and B is equal to 0. So mutually exclusive means that they do not touch one another. So if I have my general rule for probability, I have the probability of A or B is equals to the probability of A plus the probability of B minus the probability of A and B. Now the probability of A or B is 0.52. The probability of A is 0.4. We don't know what's the probability of B, and A and B together is 0. So therefore, the probability of B would be 0.52 minus 0.4, which is 0.12. 11.2. The items that a learner bought at a tuck shop were recorded over a period of time. The probabilities of the learner buying a sandwich, a chocolate, and a juice are shown in the Venn diagram below. So notice they give us probabilities. So these decimal values are all probabilities. 11.2.1. What is the probability that a learner will buy a sandwich? So if I look at the circle of sandwich, the probability of buying a sandwich would be all of these values added together. So for the first question, I'll have the probability of a sandwich is equal to 0.09 plus 0.02 plus 0.01 plus 0.04. And that is equal to 0.16. 11.2.2. Calculate the probability that the learner will buy at least 2 of the 3 items. So in our Venn diagram, at least 2 of the 3 items is where all of the circles or events intersect. So what I'm coloring in now is that's at least 2 options. And then the middle one would be 3 options. So the part in green represents 2 items, and the part in purple represents all 3 items. But at least means 2 or 3 items. So the probability of at least 2 is equals to all of those values added together. So it's 0.02 plus 0.01 plus 0.03 plus 0.04. And that is equal to 0.1. 11.2.3. Calculate the probability that a learner would not buy any of the 3 items. So we're looking for a value outside of these events. So what I can do is to find this probability, I know that the sum of all the probabilities inside of the Venn diagram is supposed to add up to 1 or 100%. So the probability of not any of the 3 items would be 1 minus the probability of buying 1 or all of these items. So it's 1 minus the sum of each of these values added together. So that is 1 minus 0.04 plus 0.02, and I just keep on adding all of the values inside of the circles. So that is 1 minus 0.43, and that means it's 0.57. So the probability of not buying any of the items is 0.57. 11.3. 7 guitar players, each with a different name, participate in a concert. 11.3.1. In how many different ways can the names of the guitar players be listed, one below the other in the program? So obviously the names cannot be repeated, and I have 7 unique names. So the answer would be 7 factorial, and that is 5,040 times. Alternatively, you could have your 7 spaces and then multiply that out one at a time. So it's 7 times 6 times 5 times 4 times 3 times 2 times 1, which will also give you 5,040 times. 11.3.2. After the performance, the guitar players wait backstage. There is a bench with only room for 4 to sit on. What will be the probability that the 4 guitar players will be sitting in alphabetical order from left to right? So for this question, we have a bench with 4 seats, and in the first seat we can have 7 different people. Thereafter 6, and then 5, and then 4. So the total number of ways in which people can be seated on these 4 seats would be 840 times. That's the total number of arrangements possible between the 4 seats. But alphabetical order, if you think of a class list or a name list, there's only one way in which to write an alphabetical list. So therefore, the probability that they would sit in alphabetical order would be 1 out of 840. 11.3.3. During the performance, the 7 guitar players sit in a line on stage. 4 guitar players are female and 3 are male. In how many different ways can they be seated if the males may not sit next to each other? Now this question is a little bit tricky. So we have 7 seats, and let's say we start with a female player. So it's female, 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 female. That leaves room for males in the seats in between. Now the way in which these 4 females can be organized is 4 factorial. Now think of males. We can start the line with males. Then we'll have male, female, male, female, male, and then the last seat would be female. So we can start with male, or we could have males in the second seat and not start with male, or a male could be in the third seat and not in the first 2 possible seats, or in the 4th or 6th seat, or if I don't have a male that I start with, I can end the line with a male. So if I take this male away, that's another type of combination that I can have. So what you see here is that there are 5 different types of groups in which males can be seated. So we have 5 groups, but if one male is seated, so let's say he takes that first position, then there's only 4 groups left for the second male. So that is times 4. And then obviously for the last male, there's 1 grouping left. So notice I'm speaking about groupings. So if we start, for example, with a male, or let's say this is male 1, he has 5 options in which he can be arranged. Once he is seated, the other 2 males have 4 options left. And once the first 2 are seated, our last male only has 3 types of seats that he can still occupy. And that total is 1,440 ways in which they can be organized with men not sitting next to each other. Thank you for watching. Remember to show your support by hitting the like button and subscribing to Mathenatic.